Hey there, geometry students. Today we're going to be talking about what makes triangles similar. So we've been talking about similar figures for a little bit now. And we know that if two figures are similar, that all of their corresponding angles have to be congruent. And we know that all of their corresponding sides have to have a same ratio, right? But when it comes to triangles, I think it turns out that we can actually know less information. We don't need to know about all three pairs of angles and all three pairs of sides. If we just know an important combination of them, we'll have enough information to come to the conclusion that the two triangles are similar. Now, there's lots of ways you could do this. You could actually play around with it and see, like, oh, what combination of stuff do I need to know? But let's just dive into it so we can start practicing. One of them is if we know two pairs of angles. So if the two angles of one triangle are congruent to two angles of another triangle, then we know that the triangles are similar. Okay? So why only two? Well, as long as we know two, obviously the third one has to be the same as well, because whatever this angle is and that angle, this angle has to be the same as this angle over here in order for them to be similar. So in this picture, we have that angle P is congruent to angle T, and angle Q is congruent to angle S. So because of that fact, we know the two triangles are similar. So you can write like a similarity statement, maybe saying that triangle PQR is similar to triangle TSU. And all because we know two angles. We also have side-side-side similarity conjecture, right? And these can be abbreviated using just the letters. So AA stands for angle-angle, SSS stands for side-side-side. Now, if the measures of the corresponding sides, that's important, of two triangles are proportional, right? They have the same proportion, then we know that the triangles are going to be similar. So this is how we've been checking, like, do we know that the figures are similar? So in these two triangles here, we have 6, 6 and 9, 8, 8 and 12. So we need to know, does 6 over 8, is that equivalent to 9 over 12? Well, 6 over 8, that's going to reduce down to, what, 3 over 4? And 9 over 12 also reduces down to 3 over 4. So because of that fact, we know these two triangles are similar by side, side, side. Same deal over here. You can compare 6 to 9, 8 to 12, 10 to 15. They all simplify down to 2/3, so they have the same proportion. So again, these two triangles are similar because of side, side, side similarity. Notice how I don't know anything about the angles, but that's okay. As long as I know about the sides, all three sides, I'm good to go. The last one is going to be a combination of sides and angles, but it must be in this order: side, angle, side. Now, if the measure of the corresponding sides of two triangles are proportional, and their included angles are congruent, then we know that the triangles are going to be similar. It's all about the placement here. The angle has to be between the two sides. Otherwise, it wouldn't be SAS, it might be ASS, which is not a good word. We don't use that in geometry. So it has to be side, angle, side. So for example, here, we've got a 16 and a 12 with an angle 70 between it. Here we've got a 15 and a 20 with a 70 between it. Remember to compare your corresponding sides. So since 12 is smaller than 16 and 15 is smaller than 20, I would compare the 12 and the 15. So 12 over 15, and I want to know, is that the same as 16 over 20? Well, 12 over 15, let's see, 3 goes into that, so that would be 4/5. Took me a second. And 16 over 24 goes into both of those, also 4/5. So because it has the proportional part taken care of, and the angle in between those two sides is congruent, we know the triangles are similar. Same deal over here. this is what we have, those nested triangles, remember? So you can compare 6 over this whole side is 12. Is that the same as 8 over 16? It is 1/2 for both, and it has this shared angle, so A is the shared angle, which makes it congruent. So we have these 3 conjectures, okay? These 3 conjectures which tell us if 2 triangles are similar. So let's do a little bit of practice, okay? Some of these numbers are hard to read. I tried to make them darker, but let's just go through maybe a couple together, and then I'm gonna have you pause this video, and you're gonna do the rest of the 1 through 12 by yourself. So let's look at this first pair of triangles. I've got a pair of congruent angles there, and a pair of congruent angles there. So I know that these 2 triangles are similar by angle, angle, similarity. I use AA with the squiggle, because remember, the squiggle shows me that if they are similar. Looking at number 2, let's see, I have 2 pairs of sides and the angle between. I still need to check the ratio though. So is 1 over 2 the same as 2 over 4? Yes, it is. So these triangles are similar by side, angle, side, similarity. Let's look at maybe number 4 right here. We again have 2 pairs of sides, a pair of angles. The angles are between the sides. So let's check. Is 3 over 6 the same as 4 over 9? Well, 3 over 6 is 1/2. Is 4 over 9 1/2? It's not. So for number 4, unfortunately, they are not similar. Okay, so go ahead and pause this video and try the rest of them on your own, and then unpause and see how you did. Okay, let's see how you did. The ones I want to make sure we talk about are the ones that are not similar. So number 7 doesn't work out. Even though the sides have the same ratio, 6 over 12 and 7 over 14, the angle that's congruent is not between the 2 sides. It would need to be this angle up here and this angle over here, but that's not where the angle placement is, so that's why they're not similar. Same thing with 12. I just have 2 pairs of sides and not a pair of congruent angles between the sides, so that one doesn't work either. 10, even though they mark all 3, that's okay. I just need at least 2. So as long as I have the 2, I'm good. Okay, turn your page. Let's see how it goes. All right, given that RS is parallel to TU, or UT, and we can see that that's marked on the picture, and RS is 4, so on and so forth, everything's marked. Find X and a couple of the sides. Which triangles are similar? How do you know? Okay, so let's write a similarity statement. I don't have a ton of room there, but I can write one. So let's say triangle UTQ is similar to triangle. All right, now remember, when we name our similarity statement, it's very important that we put the letters in the proper order. So I need to know, what does angle U correspond with? Because these lines are parallel, I'm going to look for my Z. When I draw in my Z, I see that angle U is congruent to angle S. And similarly, if I draw my Z the backwards way, angle T is going to be congruent to angle R. So T was here, so we got R. And then obviously this angle RQS is congruent to angle UQT because they are vertical angles. So I know these triangles are similar because of angle-angle similarity. So now that I know that they're similar, I can go ahead and set up proportions and solve for what's missing. I couldn't set these proportions up unless I knew for sure that my triangles were congruent, or not congruent, similar triangles. There we are. So let's see. RQ corresponds to TQ. So if RQ is x plus 3 and TQ is 2x plus 10, that can be one of the ratios in my proportion. And then I know that UT corresponds to SR. UT is 10. However, I didn't start with that one, did I? I started over here. So I need to have 4 on top. I almost made a very crucial mistake and didn't compare the proper sides. So since I started over here for my first ratio, I need to start over here for my second ratio. Okay, let's go ahead and cross multiply. So we've got 4 times 2x plus 10 equals 10 times x plus 3. Now we would just go ahead and distribute. Sometimes we do this without writing this step down. So I have 8x plus 40 equals 10x plus 30. Let's move some things around. 10 is going to be equal to 2x, which leaves me with x equals 5. X is 5. Now I'm not finished because it also wants to know what RQ and QT measure. All you have to do is plug it back in. So since RQ was x plus 3, 5 plus 3 is going to be 8. And we want to know QT. QT is 2x plus 10. 2 times 5 is 10. 10 plus 10 is 20. Yeah. Okay. So let's do a little bit more practice with just finding missing sides of similar triangles. Setting up our proportions. There are multiple variables in these. So let me just start us with, I'll do a tricky one to start with. How about we start with number 2? Okay? So let's say we want to find x. This is one of those nested triangles. And they already told me that these triangles are similar, so I don't need to worry about proving that. So let's say I want to find x. So I can compare x over this whole side measures x plus 9. Remember, not multiplied, but adding x plus 9. And then I can compare that to 16 over, let's see, 16 plus 8 is 24. So over 24. Go ahead and cross multiply and solve. I need a calculator to do 16 times 9. 144. We got 24 minus 16x gives me 8x equals 144. So x equals 18. Now, I could use this, like plug it back in and then use that to find my variable for y. However, just in case I made a mistake, I'm going to solve for y without having to use what I found for x, just to make sure I don't make another mistake if I made a mistake the first time, which I didn't, but it could happen. So to solve for y, so y is here, y is going to correspond to the 7.2. So I can say 7.2 over y would equal, and then I would compare 16 again to 24. So 16y equals 24 times 7.2, which is 172.8 divided by 16. Y is going to equal 10.8. And that's okay to get a non-integer answer. It's okay to get a rational number. Again, go ahead and press pause on this, and I want you to do examples 1, 3, and 4. Okay, so take a minute and look this over. Pause it if you need to. A couple things to note. One was pretty straightforward. You can see I made a mistake. That happens. For 3, you had to be careful with what you were comparing because, again, if we have these parallel lines, the corresponding sides aren't the ones that are like right next to each other. So like x doesn't correspond with y. Y corresponds with 23, and x corresponds with 38.6. Over here, you have to do that thing where you have to add. So this side is 30, and then the whole side is 40, and then this side is 32, and then the whole side is 32 plus x. Okay, let's look at 2 more examples. We want to explain how we know that the triangles are similar and then find the value of x in the picture. So in this first one, at number 5, we've got a pair of congruent angles there, and that's all that's marked. However, I have a pair of vertical angles here. So I know my triangles are congruent by angle-angle similarity. So because of that, I can set up a proportion. Remember, a proportion is when two ratios are equal, and we can solve for x. So 90 corresponds with 135, and 120 corresponds with x. Cross multiply, 90x equals 120 times 135, which is 16,200. Divide that by 90, and x is 180 feet. I'm using feet because it gave me units in the problem, so I figured I should be consistent. Looking at number 6, again, assuming that that's the right angle there because it's a clock tower, we have angles or triangles are congruent by angle-angle similarity. So because of that, we can set up our proportion. 4 corresponds to 10, and 5 feet 6 inches, so 5.5 feet, so not 5.6, 5.5, because 6 inches is half of a foot, over x. 4x equals 55. 55 divided by 4, x is 13.75 feet. If you want to turn that into 13 feet and, what is that, 9 inches, that's fine too. Okay, your assignment now is to do these problems from the textbook in your notebook. Consider them classwork, but if you don't finish them during class, they are homework, and we will check these together as a class the next time we're together. So it's 1, 2, 3, 4, 5 different problems, all having to do with similar triangles. Before you break off and do that, though, I want you to make sure we get all of our important information into our toolkit. Okay, so we have learned that there are 3 similarity shortcuts: angle, angle, side, 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 and side, angle, side. These definitions are slightly different than the ones we just took in our notes. They're a little bit more abbreviated. So if you need to pause this video so that you can copy this down, feel free to do so because we've already discussed them. So we have our first one here, which is angle, angle. Make sure you include the picture as well as the definition. Then we have side, side, side. Again, please include the picture as well as the definition. And then we have our last one. I'll make this a little bit bigger so you can see all the stuff at the bottom. I'm not as worried about you copying all of this down here. However, if this is something that's confusing you, it doesn't hurt to have more information in your toolkit. Okay? All right, thank you guys. If you have questions, shoot me an email and we will discuss this together soon. Take care.